Okay, 6 pieces of AI news for you, and we'll start with a banger. Yuval Harari is not the person I would expect to generate AI news. He's an author, but one of the things he suggested that I think is compelling and correct is that the likely initial path for AI personhood is not philosophical because there's really no answer to that. It is not an intelligence test, which some people have suggested. It's legal. Fundamentally, if an AI is capable of autonomously incorporating itself, it is by definition a legally defined person. Now, it can't vote, and that's probably a good thing, but it would have the same protections as a corporation would have. I think that is likely to happen in 2025. I don't know if that's good. I don't know if that's bad. I just think that given the level of autonomy that we're seeing in the space, given the simplicity of incorporation, someone is going to figure out how to give an LLM a mission to incorporate, get it done, and the LLM will be legally a person. And that's a couple of months away. Like, that's close. Now, I don't think we're going to see a significant share of corporations be AI in 2025, simply because there's a lot of corporations and not every AI use case requires this, and this will remain a bit of an edge case. But it's worth paying attention to, because anytime you talk about artificial intelligence, people immediately start thinking about replicants, and they start thinking about Blade Runner, etc. And I think that Yuval Harari actually had a really good thesis for where this is going to go. All right, number 2. Microsoft has attempted to patent RAG. Retrieval-Augmented Generation, that everyone in AI has been doing for a while. They've decided they're going to call it, I'm getting this right, Response Augmented System, something like that. They changed like a couple of words, right? And they call it RAS, not RAG. I'm going to link it. And they filed it on Halloween this year, October 31st, 2024. The thing with patent applications is, one, they're not immediately granted, so nobody building in the space with RAG has to stop what they're doing. And two, you can object to them with prior art, which means if you've been doing something that is substantially similar, you can say so. And so I would expect there to be a lot of objection and pushback to this, because we've been using RAG for a long time in AI, certainly a long time before October 31st, 2024. I'm not quite sure why Microsoft decided they could get away with trying to patent that. Number 3, Polymarket is worth paying attention to because of how they performed in the US election this past week. This is a blockchain-based solution. It is not crypto. I would argue it is probably the first blockchain-based solution that is not crypto that is widely understood and used across the world. In this case, they did $4 billion trading on the election, and they were able to call the race 2 to 12 hours faster than official news outlets. So that's a significant improvement in an election with consequences that will echo across the globe. Getting that right faster is a big achievement. And I want to call it out because I think it's the first scaled up use of blockchain we've seen outside of crypto. All right, number 3, Google dropped a model labeled Gemini 2.0, and it was briefly available. This is the same thing, right? They dropped them, they're briefly available, and then we hear rumors about them. In this case, this model was very, very fast, but failed the strawberry test. The strawberry test is where you ask it to write strawberry, but because LLMs do not necessarily include logical checks by default, it can have trouble getting the number of R's in strawberry correct because there's multiple R's in the same place. So it failed the strawberry test, which doesn't really argue for a super smart model. I'm not entirely convinced this was actually a 2.0 model. It may well have been an accidental leak and a mislabel. We will see. We probably will never really know, but we'll see what 2.0 looks like when it actually releases. I'm willing to bet you, though, whenever 2.0 really releases, that same week 0.1 is going to drop. I think that OpenAI is just holding it back, and they want to be the last horse at the corral. All right. What, 1, 2, 3, 4. I think we're at number 4 now. Yeah. So 0.1, you were wondering about that leak. The icons in Windows. I know you didn't expect me to go there. So everyone wonders, like, what are these things going to be used for when they're more advanced? And one of the classic uses is coding. And that's where I get to icons in Windows, because it suggests something very interesting. Someone said, again, it's a claim. I haven't seen a demo yet, but they said that during the brief window last week when O1 is open, they were able to code up icons in Windows with a world model, icons that had physics and weight to them, without instructing the model on a lot of physics and weight, which meant that the model understood enough about physics to code up icons that looked and behaved and bounced around 3D icons like they were in the real world without much instruction, which suggests some degree of practical world model, which would be a big deal. Okay. And number 5, this one's super nerdy, but it's really important. One of the things that is hard about training very large models is that it is hard to physically put the chips in the same place, and it is hard to make sure that all of the chips lock up and finish a task at the correct point in the training sequence with the correct response. The traditional approach to LLM training does require all the chips to work in sequence. And when you get a very large number of chips, like 100,000, one fault on one chip can screw up that entire data center until it gets fixed. Now, the leader here has always been Google, because Google has been running huge data centers since before anybody else. They have developed more work around fault-tolerant architecture at scale than anybody else I know. They actually did train Gemini on a multi-data center footprint, which, as far as I know, is the only model to be trained on a multi-data center footprint. And the thing is, that doesn't automatically make it smarter. And so that's why these other models have been able to keep up, is because they have things like synthetic data figured out better than Google, et cetera. But OpenAI knows, and Anthropic knows, that they have to get multi-data center figured out to scale, because there's just limits to footprint on data centers. And so they need, for these very large training runs, to not just have to put 1 million chips down in the same place, but to actually figure out a fault-tolerant architecture that will enable them to add more chips and scale. Because the other factor with chips is that at a certain point, because of the costs of fault tolerance and because of the transmission costs that go into a single state maintenance across a huge number of chips, like the speed of light becomes a factor because you're actually like transmitting things back and forth. You actually get diminishing returns on extra chips to a point where it may not be even worth it after a certain point. So what you should hear from that is not, oh no, we don't have any more sort of intelligent scaling capability because of the speed of light in chips. That is not the correct take. The correct take is we have some inherent architectural flaws with assuming that you have to do training runs with locksteps across all chips at once. And we have got a solve for that already on the Google side. OpenAI is working with NVIDIA on another solve. Jensen was talking about it and saying that he doesn't see an inherent blocker to it. And that fundamentally we should be able to do multi-data center training, which would involve not having to transmit and keep all of the chips in lockstep across all the data centers. And that in turn unlocks the laws of scaling again. And you aren't stuck on adding another chip. You aren't stuck when a chip fails, etc. I know that was a long sort of explanation. I have a whole link I'll post as well. But I think it's important to understand the underlying architecture that powers these models, because it demystifies it. It also helps us to understand what's really going on as we head into what is likely a training run aiming for artificial general intelligence in the next year to 2 years. Cheers.